So the function is 3 minus x, and it goes from 4 to 8. So all the y values are negative. So it only exists under the x-axis. So if it only exists under the x-axis, you're going to shade back up towards the x-axis. Okay, so essentially A and B are the same question. A and B are exactly the same question. One is in words, one is in calculus or integral notation. Okay. So there's a couple different ways. This guy right here. I'm not worried about the negatives. I know my finished answer is going to be negative. I know my finished answer is going to be negative, but I'm not worried about that right now. It's a trapezoid. That's one way to do it. You can use trapezoid, right? You can use area of a trapezoid. Base 1 plus base 2 times the height divided by 2. You can do that. Or it's really a rectangle with, you can do it this way. Oops, let me see. Rectangle with a triangle. You can find the area of the rectangle on top, 1 by 4, and then find the triangle and then add them together. You can do either one. It doesn't matter. It doesn't matter how you do it. If you do it correctly, you would get, so you're going to get, let's see, I'll use the base of trapezoid. Let's see. So we get area equals base 1. I'll use base 1 as the smaller, so that's 1. The longer base, let's see, base 1, base 2, was that 5? Since it's kind of on its side, the height is going to be here, so the height is going to be 4 divided by 2. So 6 times 4 divided by 2 makes 12. The only thing is, it's got to be a negative 12 since it's below the x-axis. Move all this stuff over here. Okay. A and B ask essentially the same question. There's no difference. Just one is in words, one is in integral notation. Okay. Okay, so last thing. We won't finish today, but we won't have much time tomorrow to finish. So the rest of the time tomorrow I'll give you to start on your assignment. Okay. So here we go. So given, they give us something. They say, okay, so from 0 to pi, sine of x is the function, right? Sine of x is the function. So if I find area under the curve for sine of x from 0 to pi, the answer is going to be 2. Using that, find the area of the rest. Okay, so the first thing I'm going to do is I'm going to draw a picture of what I know and what I'm trying to find out. Okay. Pi over 2, pi, 3 pi over 2, 2 pi. So regular sine of x. So I'm going to draw the given part. So sine of x. Well, sine of x is going to look like that. All right. That's what sine of x looks like from 0 to pi. And then it continues. Like that, right? So I have 2, so from 0 to 2 pi, that's one phase or one cycle, or whatever you want to call it, of pi. Okay. So the green is what they've given me. pink is what I need to find. So they've told me that this is 2. Area of that's 2. So A is area from pi to 2 pi. So what is that going to be? What is area of the from pi to 2 pi going to be? How do you know? How do we, my question is, how do we know? How do I know the green's 2? Because they told me. Given. Right? So what is my reason for that guy? Mm-hmm. How do we know? Mm-hmm. The same distance, right? This is the same distance, I agree. So the base is the same, but how do we know the heights? How do we know exactly the same? How do we know everything's the same? How do we know the green and the pink are the same shape, just reflected? How do we know that? And you do know. The answer is you do know. How do we know that though? Mm-hmm. No, it does. It has that shape. But how do we know that they're exactly the same? How do we know that they're not a little bit off, a little bit different? They both have height of 1. What else? Keep going. How do we graph sine? Like what makes us graph how do we graph sine like that? Where do we get all that from? How do we know that sine looks like that? From the unit circle, right? And the values, aren't the values exactly the same? The y values exactly the same here as they are here? Aren't they exactly the same? They're just opposite, right? That's where we know it's the same. Okay? Because the values are the y values here and the y values here are exactly the same. They're just opposites of each other. That's how we know they're the same. Don't just take for granted that my picture looks, oh yeah, they look the same. No, because the unit circle, we could check our unit circle to see the y values. Okay? So yeah, that's why it's -2. Okay? So what would B be? 0. Since we know that they're both exactly the same, but one is positive and one is negative, they're opposites of each other, has to be 0. They cancel each other out. Okay? Not always going to be the case. Not always going to be the case. So that's what I'm saying. Like it's not going to be. It might not be true for cosine, tangent. It might not be true for those guys, but for sine it is. What was I going to say? Here's the question though. Without the picture, or let me phrase it a little differently. With the picture, this question's super easy. Without the picture, I've seen a lot of people struggle on the questions like this. I've seen a lot of people struggle on questions like this. They see this question and they freak out and they just like they don't know what to do. Draw a picture. Okay? If the function is simple, relatively simple, what I mean by simple is it's just sine, right? It's not sine squared of x plus cosine squared of x minus tangent of x. That one's not simple, right? That one we can't draw. But if it's just sine of x, if it's just linear, if it's just something like that, draw the thing. Just draw the thing so that it keeps it as simple as possible. Doesn't have to be hard. Doesn't have to be hard. Okay. All right. So the last thing, let's see. Okay, let's do letter C, and then we'll be done for today. Letter C. So from 0 to pi over 2. From 0 to pi over 2. Again, with a picture, it's not too bad. What's the area of that shaded part going to be? 1. For the same reason we knew that it was negative, because the values repeat themselves, right? These y values here are the same as these y values here. They reflect, right? We know, how do we know? From the unit circle. So it's just going to be positive 1. Again, very easy when you draw the picture, okay? So the last part we're going to do is we're going to do a little bit of messing with it, okay? And then some calculator. These are the instructions on do exactly what we just did using the calculator. Okay, we don't get to use the calculator a lot in this class, but it's a great way to check your answers by using the calculator. Okay, and we'll finish the rest. We won't take that long. It'll take probably like 10 minutes to do tomorrow, and then the rest of the time I'll give you to start on your assignment.